Ron, thank you very much. It was really 25 years ago. We met first time in Nancy, in France, 2000, December, and we had the opportunity to establish the European Association of Chemistry and Environment. We were together in the board of that association many years, and I have opportunity, I can say that I have lucky to hear a lot of your lectures, really excellent lectures from excellent lecturer. Thank you for company during the last many years ago. But first of all, dear colleagues, dear friends, it is a great honor for me to be the first to give this plenary lecture. In a way, also as the host of this conference. But first of all, to put this conference is taking place in very important periods for us in Serbia. There have been no classes in our university for more than half a year since 1st of December 2024. In the fight for the fair, for the normal political system, and in the fight against corruption in Serbia, students have chosen blockades with daily peaceful demonstration as their methods. At some events, there were up to 500,000 students, professors and citizens. You can see one of our meeting in Belgrade, only several months ago. In terms of number, they were biggest political events in the recent history of Europe. We wish them, we wish us success in this, in our great fight. Please, one big applause for students of The title of my lecture today is very often in the presentation. Polycyclic alkanes as a forensic tool in the identification of petroleum-type pollutants in the environment. But only for the beginning, as a reminder, to see what is the biggest global problems today in the world. Of course, on the first place, increased emission of CO2 and other gases, covered by, firstly, Kyoto Protocol, and after that, Paris Agreement. Second, Montreal Convention addressed measures to prevent the depletion of the ozone layers caused by anthropogenic influences. Emission and trade of persistent organic pollutants covered by the Stockholm Convention since 2004. Rotterdam Convention concerning hazardous substances and waste. And finally, in the field of the environment, the most important convention is Aarhus Convention. It was adopted on June 1998 and refers to access to information, public participation, and access to justice in the field of environmental protection. Unfortunately, the convention that is least respected is the Aarhus Convention. Very often, data on environmental quality, especially in the context of accident, are hidden from the public. In some countries, proper monitoring system cannot be established, so there is no data. From the beginning of the 20th century, for more than 100 years, oil has been a material of general importance. It is a subject of interest of economists, political scientists, the subject of research in humanities, the subject of military experts. There is an opinion that almost all wars from the beginning of the 20th century to the present day have been fight over oil explicitly or implicitly. The text on the other side of chemists, organic geochemists, geophysics, and geologists is to help in the search for new oil and gas deposits and assess the origin and geological history of oil. However, Given that oil is the mixture of a huge number of organic compounds, it is at the same time the subject of research by chemists and ecologists with the aim to finding methods for identification, assessment of environmental fate, and remediation. Our research group from Belgrade University, Faculty of Chemistry, was established at the mid of the 20th century by Professor Branimir Jovančićević. Originally, our research group is in the field of organic geochemistry. We have investigated kerogen, crude oils, humic substance in recent sediments, etc., etc. But in the mid of 19, a lot of us from our research group went a little bit in the field of environmental chemistry, and we made use our knowledge of kerogen, crude oils, and recent sediments, organic matter and recent sediments in environmental chemistry. Me personally, I was responsible for the petroleum, for the bitumen in sediment rocks, and since that period of time, I'm partly in the field of organic geochemistry, but on the other side, partly in the field of environmental chemistry. In spite of the development of petroleum exploration, transport, and refining technologies, petroleum and its refining products continue to be one of the most evident environmental pollutants. Consequently, studies on the environmental fate of petroleum-type pollutants remain to be an actual scientific interdisciplinary problem. What is important? To see possible pollution seeds. First, exploitation on boreholes. Second, collecting states on oil fields. Transport by car, tanks, tankers, or oil pipelines. Processing in refineries. Transport of finished products. Storage of finished products. And of course, the use of. But when we are talking about petroleum as pollutants, firstly, we have to give organic geochemical input for better understanding the composition of the oil and how many compounds from oil can be really dangerous for the environment. With the aim for identification, fate, and remediation of petroleum-type pollutants in the environment. Remediation, there are a lot of approaches. Bioremediation is maybe one of the more interesting. In ex situ conditions or in situ conditions. Concerning the fate, for example, we can see changes of, for example, saturated hydrocarbons in petroleum during the process of biodegradation. Here you can see what happened with normal case during the period from November 1997, September 1999, for example, and biodegradation of normal case in the fraction of saturated hydrocarbons. But identification is on the first place. Why? The amount of soluble organic matter in the soil, groundwaters, surface water, is not precisely defined. Theoretically, can be in the very wide range, from 0% to 100%. For example, there are a lot of samples of soil without organic matter. On the other side, there are some samples with 100% of oil. For example, seeping oils or oil or lakes. And because of that, only identification measurement of amount actually of soluble organic matter in a sample of environment is not enough. We have to find some, better approach to be sure that isolated soluble organic matter is really petroleum pollutant. On the other side, can be native organic matter. And thanks to different thermal maturity of petroleum on one hand, and the recent sediment of bitumen on the other, we can use several classes of organic compounds. For example, normal case may successfully be used for differentiating the petroleum-type pollutants as anthropogenic organic substance from native organic matter in recent sedimentary formation. Being a more mature organic substance compared to recent sediments, bitumen and petroleum contains a higher amount of heavier carbon isotope, for example. However, actually, you can see on this figure, for example, this is one typical petroleum pollutants, because this distribution on alkanes and isoprenoic crystalline phyton are typical for saturated hydrocarbon fraction of petroleum. Uniform distribution of normal alkanes. On the other side here, we can see distribution of normal alkanes in a native organic matter with terrestrial origin. Predominance of C25, 27, 29, 31. Also, isotopic composition of this sample for these normal alkanes and isotopic composition for this sample as a proof for the native organic matter on the one side and the other side petroleum-type pollutant. However, I have to say that the best approach, to best compounds, organic compounds in crude oil as a tool for identification petroleum-type pollutants are polycyclic alkanes. First is terranes and, of course, terpenes. But for better understanding terranes and triterpenes and all compounds in crude oil, I have to give a small organic geochemical introduction. Namely, organic geochemistry informally was established, let's say, in 1931. German scientist Alfred Tribes identified porphyrins in crude oils. After that, organic geochemistry was growing up rapidly, especially in the period 17 and 18 and 19, and that period of time, organic geochemistry was very, very important science within natural sciences. And thanks to organic geochemical investigation for the long period of time, formed maybe the most important cycle in the nature, cycle of carbon. Here we can see one circle, small circle, and big circle with connection in one small point here. Actually, small circle is circle of carbon in the biosphere, and this is the circle of carbon in the geosphere. Actually, all organic matter in geosphere is coming from biosphere, in spite of the fact that only 0.001% of organic matter from biosphere is coming from geosphere. In spite of that fact, in geosphere there are 2,000 times more organic matter than here, thanks to the fact that accumulation of organic matter was during the extremely long geological period from Cambrian till today, 6 million years. And the objective investigation of organic geochemistry is second circle. Very simple schema is presented here. And here we can see the position of oil and the gas. For oil, we can say that represent the migrated and accumulated product of diagenetic and catagenetic transformation of organic substance of sedimentary rocks. From the organic geochemical point of view, it is one of the end of products of the transformation of organic matter of sedimentary rocks. And I can say that I living together with oil last almost 40 years. My diploma work was in the field of correlation with the oils, southeastern part of Pannonia Basin. And after that, almost 40 years I'm in this field. I have investigated oil as one positive material, as a so important fossil fuel, and on the other side, I have investigated oil as danger pollutant in the environment. Once again, during the diagenesis, folic acid, humic acid, and humin will form kerogen, and after that, during catagenesis, metagenesis, and metamorphism, from kerogen, bitumen, oil, gas, and graphite will be produced. In crude oil, there are a lot of compounds. Very often I say to my students that all organic compounds which you learn in organic chemistry you can find in the petroleum, in the oil. And really that is true. However, all compounds we can put in only 4 fractions: saturated hydrocarbons, aromatic hydrocarbons, polar nitrogen, superoxygen compounds, and asphaltates. The most important are so-called biological markers, biomarkers, or molecular fossils. Compounds in oil which precisely find origin, precursor materials, and thanks to that we can define the origin and precursor materials of all oil or petroleum. Analytical methods are relatively simple, and it's interesting that analytical methods in organic geochemical and environmental chemistry and environmental chemical investigations are not similar, same. Only interpretation is different. In organic geochemical research, our aim is to define origin and geological history of the oil. On the other side, in the field of environmental chemistry, same results we can use for, no same results, same approach we can use for identification, fate, and remediation techniques of oils. In former time, this was the procedure for isolated compounds for GCMS analysis, and I remember very good 30 years ago I had to saturated hydrocarbons treated with carbamide to obtain adduct and non-adduct. Adduct was normal alkanes, non-adducts branched cyclical alkanes, and after that to organize GCMS analysis. For example, this is saturated hydrocarbons total, after that normal alkanes, branched cyclic, and after that GCMS analysis for steroids and terpenes. Nowadays it's not necessary because nowadays it's enough to isolate it only saturated hydrocarbons, and after that do GCMS or GCMS-NS. And now finally, the most important to see what happened with steroids and terpenes during transformation of organic matter. At the beginning, we have, for example, molecular cholesterol with configuration here alpha, H, 17, H, and 20R isomerization. Also on the third C atoms, we have hydroxyl group and double bond here between 5 and 6 C atoms. During diagenesis, of course, we shall lose this hydroxyl group and this double bond. And after that, under the pressure, under the temperature, with mineral catalysts, there will be very important stereochemical changes. And we shall obtain, for example, 14 beta, 17 beta, 20R isomers. And also, we shall have moving of methyl group for this to this position, and we shall obtain diasterenes. Diasterenes you can find only in the crude oil. There are no diasterenes in the biosphere. Parallel with this process, also there is the process of aromatization with the phenolphthalein as a final product. This is the GCMS SIM fragmentogram here from this part, and we can see the peaks of alpha R 27 steroids, 28 and 29. However, after millions and millions of years, we shall obtain from that this peak number 10, 16, and peak number 20 will produce all others. But we need millions and millions of years for that. And this is one typical fragmentogram of steroids in the crude oil. This is the fingerprint. It is impossible to find this distribution of steroids in the biosphere, in the recent sediments, in the soil, or in, for example, groundwaters or surface waters. It is impossible. Once again, this peak 10, 16, and 20, 27, 28, and 29 steroids will produce all other peaks. Here there is the list of all isomers, and producing 3 cyclic terpenes for hexaprenol, C40. Also there are 4 tetracyclic terpenes, But the most interesting story is with pentacyclic terpenes type hopanes. And this is the way produced. It is well known today, and this is the result of organic geochemical investigation during the period of maybe 30, 40 years ago. Nowadays, this is well-known story about terpenes. Also, in crude oils, there are lanolin, bursa, lupan, gamaceran, and all others terpenes, and the result of all geochemical changes of terpenes for geological history for millions and millions of years, we shall obtain this distribution. The list of peaks is here, also very well known for all organic geochemical researchers, and we can say that this is one typical distribution of terpenes for crude oils. It is impossible to find this distribution in recent sediments, in soil, and in ground on surface waters. Sometimes stearains and triterpenes we can analyze in more details by GCMS-MS, also with same story with terpenes. And once again, we can see our tools for identification of all type pollutants in the environment. Difference with distribution in recent sediment is, well, we can see very easily this difference. Once again, these peaks in million years will produce this, and these peaks in million years will produce this. And because of that, we can use these distributions as a forensic tool. There is also one reason more. Together with our colleagues for microbiology group, Professor Miro Savrević, and nowadays from Vlade Beškovski, we did a lot of experiments concerning biodegradation and biodegradation of oil pollutants. And one of our experiments was biodegradation by homogeneous bacteria and fungi in the period 75 days. And we can see all what happened with normal alkanes during the period 75 days. After 75 days, with bacteria and fungi, we shall lose all normal alkanes. It's very interesting that the similar fate is with aromatic compounds. Here we can see degradation of phenanthrene, almost all methylphenanthrenes and partly dimethylphenanthrenes samples. But first paper was in 2001. The title is Stearains and Triterpenes as a tool for identification of petroleum-type pollutants in alluvial groundwaters. Diurnal alluvial sediments, Yugoslavia, at that period of time. We have country Yugoslavia, nowadays only Serbia. Also, geochromatographic migration of oil pollution from the heating plant to river sediments. We investigated Stearains and Triterpenes as a forensic tool in Tisa River. Also, we use Stearains and Triterpenes in Dinub, Đerdap Lake. Characterization of organic sediments in Great War Island in Belgrade, also Stearains and Triterpenes were very useful. We used Stearains and Triterpenes for identification of Vrbas River in Bosnia and Herzegovina, and in many, many other cases. I can say that all biological markers, but in first place Stearains and Triterpenes, are now used as a forensic tool in the court proceedings. My colleagues and me had the opportunity to be court experts in some proceedings where the subject of the criminal act was the oil. Very interesting story, and we had very interesting experience in these proceedings. Some of them were very dangerous. Also, I heard from some of my colleagues from some other countries that also they used Stearains and Triterpenes in similar situations. For example, Professor Albert Labeder had very interesting experience with some criminal act from Sakhalin oils, and in many other cases sterile certificates were used in this. And all this, our experience, Professor Jan Schwarzberger from RTH University, Aachen, and me, prepare for students several books. These books are official books for learning organic geochemistry in the connection with environmental chemistry. Fossilimetry in the geosphere, from biomolecules to hemofossils, isotopes in organic geochemistry, introduction to analytical methods in organic geochemistry, organic pollutants in the geosphere. And I can say that nowadays I am happy that after relatively for Serbian conditions rich research job, I together with my colleagues from RTH University provide interesting books from students too. Of course, our group is relatively big. We have more than 20 researchers, but in the first circle are Ksenia, Mališa, Aleksandra, Tanja, and all others. Gorica, Sanja, Milica, Snežana, Nikola, Emilija, Nevena, Zlatko. I'm working as a professor of industrial chemistry at the Faculty of Chemistry, University of Belgrade, but in very strong connection with the Institute of Chemistry, Technology and Ecology. As Roland already said, as the Humboldt scholar, I have permanent collaboration with the German institutions in Hanover and in Aachen. And very important for me and for my research group is the Association of Chemistry Environment. Until now, we organized 25 AMEC meetings. This year, in the last week of November, we shall have the meeting in Crete, Greece, and good opportunity to invite you to come to Crete to be with us. Pure environmental chemistry, very interesting papers from young researchers from almost all European countries. Ladies and gentlemen, dear colleagues, thank you very much for your attention.
Thank you, Professor Jovančićević.
Sorry for these technical problems, but I don't know what is the reason.
Very minor things.
I think so.
It's no problem. So now we have time for questions. Is there any questions from the audience? Professor Jovančićević.